sketch the following absolute value function and state their domain and range. Before this example, here we can see we can use graph transformation to sketch. For example, if you look at the y equals modulus of x plus 2, this is y equals the modulus of x shift up by 2 units. Okay, well, the part B is y equals modulus of x shift down by 2 units. Okay, so if you can see very clearly, the function can be transformed, especially can be shifted up or down, left and right. From a simpler function, you can do that. Okay, so for A and B, it is easier to get, okay, the absolute value of x. Okay, hopefully you still remember how to get that. We firstly draw y equals x, and then when I take the modulus of x, whatever below the x-axis, this part reflect about x-axis. Okay, so this is how we get y equals absolute value of x. So after we get y equals the absolute value of x, when you plus 2 means it go up by 2. As you know, previously for y equals modulus of x, it has a y-intercept and x-intercept. Basically, it passed through the origin. But now, because it plus 2, so it's go up by 2. Okay, so y equals modulus of x plus 2 has a y-intercept at 2, and also that is the minimum point, as you can tell. So for this one, the domain is x is any real number, and the y is at least 2. Okay, because this is the minimum point of the function. The other one is y equals modulus of x minus 2. So that means y equals modulus of x shift down by 2 units. The y-intercept hence become minus 2. Okay, so this is the graph of modulus of x minus 2. And then in this case, x is still any real number, but the y is at least not 2. The y is at least minus 2 this time. Okay, so we can know the range, which is the y value, from the graph. Okay, when you come to the x value, in fact, x can be any real number, because here there's no fraction. If there's a fraction, we have to make sure the denominator is not 0. There's no square root. If there's a square root, we have to make sure x is at least 0. Okay, so in this case, no square root, no fraction, literally x can be any real number. Okay, for part C and D, I will use a different method. I will not use transformation, but I will use a method that starts from finding the turning point. Okay, where is the turning point? If I have y equals modulus ax plus b, modulus, and then plus another linear function, for example, the turning point, okay, remember this, the turning point is where ax plus b equal to 0. Not x equal to 0 is ax plus b, means what's inside the modulus, and that part is equal to 0. Okay, this side, inside. Okay, inside 0. Okay, so let me show you. So for y equals half modulus of x plus 1, inside the modulus is just x. So the turning point is at x equals 0. When you sub x equals 0 into the function, you got y equals 1. So the turning point is 0, 1. Now, then we find two more points. One point can be on the left of the turning point. You choose a value that is less than 0. For example, -1. Okay. If x equals -1, y equals half times modulus times -1 plus 1, which is half times 1 plus 1. That is 3/2. So we get -1, 3/2. And then I choose another point, which is on the right, which is bigger than the turning point, on the right of the turning point. So since turning point is x equals 0, I will let x equals 1. Then the y equals half times modulus of 1 plus 1, that will be 3/2 as well. Therefore, the other point is 1, 3/2. So now we have 3 points, and we show them on the Cartesian system. So firstly, 0, 1. Secondly, -1, 3/2. Thirdly, 1, 3/2. Now you get these 3 points, you connect them, you should get the graph. Okay, and because we know 0, 1 is a turning point, so this point must be the minimum. So this graph is like open up. And from graph, we can tell the function has a minimum at 1. Okay, so the range is y is at least 1. Okay, so this is how we draw the graph using turning point. Okay, so now I do the part D as well. Now, if you are watching this video and you are trying yourself, you can pause the video, try to draw this. Okay, using the method I show here. Okay, and later you resume the video and then see whether you are right or wrong. Now, turning point is at where x minus 3 equals to 0. Okay, so the 3, 0 is the turning point. Remember, we need to find another point less than 3 on the left of the turning point. For example, I may choose x equals 2. And then we choose another point on the right. For example, x equals 5. Okay, so with these 3 points, in fact, since the x values are all positive, I don't have to draw the second quadrant. 1, 2, 1, 2, 1, 2. Okay, so 2, 1, 3, 0, 5, 2. Okay, here you are. That is the graph. And if that's the case, the range of y is at least 0, because this is the turning point, and this turning point is also the local minimum. Okay, and well, you cannot call that local minimum because it's not a stationary point. Well, you can just call it the minimum, and the minimum is at y equals 0. Okay, so these 4 functions, the first 2 I use translation. The last 2 I use the idea of turning point to work out. After you work out the graph, after you sketch the graph, then you can tell the range of the y values.